All right, we're back at the shop working on the 68 Cougar, and the owner of the vehicle would like to have his suspension modified like what they did back in 1968 with Carroll Shelby, Parnelli Jones. There were a bunch of guys that were racing Trans Am at the time, and what they found in their course of racing is to keep the tire contact patch on the ground more for performance cornering. They did a simple modification of lowering the upper control arm down 1 inch so that throughout its travel the tire would maintain a flat profile, so they call it extra camber gain throughout its travel. This is the company that sells the parts to do the modification, and just try to point out the weaknesses of the stock suspension, which was never intended for racing and street use. So there's weak points on this chassis that need to be stiffened up. We get some filler panels that will tighten up this area, one on each side, fit in here. They tighten up that whole shock tower with the brace. The cross brace that ties each side of the frame together and makes the engine cradle is this device right here. You can see these gussets that have been added, and the lower control arms at their pivot point usually just go into drop brackets that are on each side of the frame. After this has extended bolts going through the control arm that goes up and down, it will tie into here. So this will stiffen up the front suspension, reduce deflection in its travel. A lot of work to do this though. You can see this cross brace that connects the two shock towers together is going to be now a part of the suspension points, and between here and here is where the original went, and now this has got these gussets, and the bolt, it goes in here, it goes underneath, and then with the suspension pieces, bolting in here, and you've got an eccentric for adjusting your caster and camber. The bolt's going to go through and tie this thing together, so this whole suspension piece is going to be locked in as one item. So where the original suspension just went through at the end of this tower, we need to make a spacer for that bolt, and then this will come through here, and then the bolt will be on the back side with another washer. And thank God we're not doing the alignment. The guy that's doing it is probably going to be like, what the heck is this stuff? But that's what you got to do to get, anything that you modify is going to be a problem. If you wanted to, you could do this with your own item. You see, that's all they did is put like a gusset here, and you could take the original and weld some wings on there. This is the eccentric bolt, and as you put it in here, as you put this bolt in here, you'll see how, it just moves from one side to the other. This control arm goes like this. If you push it out, you're going to have it riding, with the wheels out. And if we move it in, you're going to control it. Whatever the settings are for street use are going to be different than track use. They'll probably just adjust it for being on the street. I don't know how serious the guy's going to be, but then you could have two settings and you make the marks, and then you get underneath the car, and when you're going to whatever track that you go to, you'd end up playing with this to see if it handles better. That's all you can do. Time and trial and error. We got the motorcycles.
Here we're fitting up this cross member, and we have our spacers welded in. In the front, you can see there are these tabs for the eccentrics. We actually ended up cutting those off in the back. Those tabs basically lined up this washer here, and these washers actually braze to this bolt. So we had to break that braze. Then we're going to weld these washers onto the new bolts. And on the back side, the washers have a D. Here's the bolt. So we're going to have to grind and file these new bolts to accommodate this washer. And we've cut the tabs off the back side, and we're going to actually weld those onto that cross member. So we'll still have a guide for the eccentric. Here we've made a new lower control arm bolt. You can see we filed it flat there, and after we did that, we had to weld this other washer on top. It's still pretty hot. So it's the same. Has to be in time. Here we got the base of the shock tower all cleaned up, getting ready to reinforce it. Here's the finished spring pocket or shock tower, whatever you want to call it. See the piece all welded in there, and the new upper control arm mounting point has been lowered 1 inch.
When we drop the suspension 1 inch, the angles of that upper control arm are going to keep here's the spindle, and by attaching it down lower, it's going to keep this more straight than if it was up here and the spindle was taking more of an arc.
Here's the finished cross member for you Cougar guys. There's your spacer, a few old holes, and we reuse them tabs. They're going to help keep this bolt square to locate the lower control arm.
We're working on the 68 Cougar. This is the body or the suspension modifications we did. Some of the guys were asking why would they drop the upper control arm attachment points. And if you ever see a description of a suspension, they'll either call it a McPherson strut or a short long arm suspension, SLA. The lower control arm takes the full sweep when you hit a bump. And if they were both equal, your spindle would be taking a huge arc. When they use a shorter arm up on top, it's keeping it close to the body, and when it goes up, the spindle has to stay more straight up and down instead of taking an arc. When you're racing, or even wear and tear on tires on the street, you would want them to go up and down even instead of scuffing the outsides of the tire. That's why they always rotate the tires from the front to the back, so that you get even wear on all your tires. On a track, when you're going stuffing into a corner, they don't want to ride on the side of the tire, they want to ride on the bottom of the tire. More contact patch, better grip, and you can go faster around the corner. That's what we're trying to achieve. With the attachment points that he's got now, with everything tied, you'll have a brace up on top. These pockets reinforced, keep that suspension point tighter, and there'll be less flex. This thing should feel a lot more firm, and the tires should stay planted better on the track than if we would have just left it alone. In our next episode, we'll be coming back to the shop and replacing all these rubber bushings. Some guys go with the urethane. It's a real harsh, firm ride, but it tightens everything up, no flex. He's going with the rubber. And you can see this one's pretty well worn. That's a whole job in its own. If you've got a Falcon, a Mustang, or a Cougar, and you want to get good handling and you don't have the money to buy one of them fancy front suspensions with the rack and pinion and all that, just tightening up all this rubber and putting some new shocks and some sway bars and make your car feel like a new vehicle, and with new modern tires like radials, it'll be way better than being back in 1967. They didn't handle very good back in the day, and when they got worn out and they got rusty, they were even worse. So we're going to try to take back time.